Oh, that was so good.
I really like the song with the stuff.
Oh, the music of the things at the place at the time.
With those people.
Oh, yeah, they're good.
Simple harmonic motion, no good.
Yeah, 10 out of 10, would see again.
Google them.
Yeah,
Great. Now we're on to simple harmonic motion.
Yeah, but now we're doing the graph search. So remember an equation from last time?
You do. It was about displacement, and it equaled the maximum amplitude times sine 2 pi f t.
Yeah.
And there was one for cos as well, but we focus on the sine one for these graphs.
And remember that is when your displacement is at 0 when you're at the origin.
So we'll start with the displacement time graph, because that's the easiest one to think of.
Yeah. So it's a sine graph.
It is, and because of the sine, that's where we get this equation relating them. So the displacement is 0 at time 0, and then it is literally just the sine graph.
Yeah. Then we have the acceleration.
Yeah.
We like this.
Call this t.
Oh, okay, yeah.
And this 2t. So we've got some points to relate to each other. So if we have the acceleration one.
Yeah, it'll be in the other direction, because remember in the defining harmonic motion, the displacement is the opposite direction to the acceleration.
Yeah, so it's going to look like this.
So if we were to draw...
But this point would still be t, and this point would be 2t.
At 2 different points.
Where it crosses these axes.
So
that's a lovely pendulum.
That's going to be 2 pendulums, well, it's going to be 2 pendulums at 2 different points, they are.
Oh wow.
Yeah, and this is these examples, so this one, let's say x is at its maximum, and a is at its negative maximum.
Yeah, because they're inverse and negative.
Yeah. Finally, we have the velocity graphs, and that's quite different now.
It is, it's...
Oh,
no, Truth.
I know.
Velocity time graph.
Yeah.
Now, when these things equal 0 in this y-axis...
Our velocity will actually equal its maximum.
Yeah.
Because when it reaches the middle, it is going the fastest it can.
So, these things both equal 0 at this axis as well, so don't forget that. So the velocity starts up here.
So it's like a cos graph.
At point t, it's going to be a maximum and negative, so it's going to cut through there and be maximum there.
Yeah.
And then at point 2t, it's going to be maximum again, so it's going to cut up there and be maximum there at 2t.
Yeah.
Then it'll drop down again. So in relation to each other, this is what they look like. And you have to remember this, and often it does come up as drawing them for points.
Yeah, and the good way to think about it is to work out where it would be fastest in the pendulum and why acceleration and displacement would be 0 from there. And that's of course changed from the cosine one, which does happen sometimes. Yeah. You've got to think about it a different way.
So for the maximum velocity, we've got a whole new equation.
Because you actually had to find out what that is sometimes.
Yeah.
And that equation is up here, but I'll draw it again.
So Vmax, the maximum velocity at any point in this pendulum, or if it's a spring, is 2 pi f.
I'm going to write out of A in space.
There we go.
That kind of fits.
It's just plonking numbers into a formula, so we don't need to go through that. The graphs are the hard part.
I think, is it running your formula booklet? I think so.
Yeah, that one's in your formula booklet.
So you just need to apply that, put the Vmax in.
Yep.
Yeah.
That's all that really, it's all sorted. Next we're on to energy, which is more graphs and they're a bit more weird.
Yeah.
So we'll see there.
Oh.
I think we should go see him again, Triv.
Again?